Hi, I'm Jag Srai from the Institute for Manufacturing, Department of Engineering, University of Cambridge, and really part of the CMAC program on supply chains. I'm going to talk today about scale-out scenarios for the microfactory supply chain, a key feature of our work over the last year. So in terms of scale-out scenarios, I'm going to first talk about molecule and process technology selection and how these are critical to supply network design. Here we're going to consider workflows, methodology, and the analysis tools we're using. Then I'm really going to talk about microfactory operations and how we're using the digital twin concept to explore scale out and scale up options. And a key decision for us is, are microfactory digital twins distributed or co-located assets? We are going to then draw on a microfactory implementation case study across a separate sector where we look at cost scenarios, service levels, and incorporating the real world factory realities of startup and shutdown. I'll then talk about distributed manufacturing, that it's not just about the technology, but a broader ecosystem of challenges. Then I'll wrap up with a summary and some thoughts on future research. So in terms of molecule and technology selection as part of a broader supply network design narrative, this is the workflow we've been following, right the way from molecule selection, product specification, particle design, process design, and a series of workflows that allow us to identify attractive product process archetypes. So in the first part of this work, we've tried to identify what are the product archetypes that are attractive from a volume and variety perspective. And we had identified in previous work that continuous manufacturing technologies are particularly attractive at high volume, low product variety, low SKUs, but also at the very low volume, high variety SKU. So that's one aspect that we've been trying to identify in our work. The second area we're trying to look at is around product process archetypes. So what are the process technologies that can operate at the scale we've identified in the previous work? And I'll talk more about particular technologies. And finally, the supply network design task and how we go from particular unit operations to particular factory footprint, the location of those assets, and the implications for service and inventory. So selecting molecules and process technologies. In the first part of this activity was all around molecule selection. So molecule selection for continuous processing, we identified a number of key variables to consider. The market need, addressing product shortages, essential medicines. Some of the criteria that we could use to identify attractive molecules for continuous processing development. Then on process technologies, we wanted to look at multiple decision criteria, the analytic hierarchy process method, for identifying what are the technology choices. And here we looked at a number of process technology variables, but added to this the traditional supply chain variables around responsiveness, cost, inventory. And this has sort of led us on to evaluating microfactory modular unit or combinations. Should these be centralized or distributed becomes the next task. Do we look at single product manufacturing or multi-product manufacturing? And what's the business case? Are we going to secure that on product flexibility, the use of single or multiple products, the capital involved, and the asset utilization you might expect. Then I talked about process technology selection. So this involved ranking of a series of attributes for reactor technologies on that earlier volume variety matrix. So we can see here microwave, microreactor at small volume, CSTR cascade at higher volumes, and more conventional technologies at higher volumes still. So this allows us to narrow down the technology operating windows for particular reactor types. Then comes this question around microfactories. Should they be distributed or co-located? A few words on distributed manufacturing. This really looks at the footprint of manufacturing assets. So do we have them distributed or co-located in a farm of equivalent technologies? Now, distributed manufacturing has been underpinned by a number of variables: digitalization, localization, the ability to personalize products, the adoption of new production technologies such as continuous or 3D printing, for example, and the role of designers, producers, and users in part of that design process. So I'm going to share a worked example we've done on a real-world case study in the 3D printing environment to look at some of the options of. And here we see 4 alternative manufacturing footprints where there's degrees of centralization and distribution. And we're trying to identify what is the most attractive footprint going forward. So part of this is really trying to understand in a given site some of the activities that need to be undertaken. For example, in the receipt of materials, the allocation to a particular production unit, the dispatch. So it's not just about the unit operations that we're doing our technology research on, but the factory as a system. And this allows us to start to look at specific configurations, the 4 depicted in the left of this chart, for example. But these include the shop floor activities I've just described. And our modeling looks at static models for identifying operating cost comparisons with the alternative configurations, but also time-based dynamic analysis to look at inventory levels and service options. So are we delivering in the time that's available to us and expected of us? And what inventory do we need to hold in order to provide that security of supply? Now, in the pharmaceuticals context, we've taken an example. This is analgesics, looked at the current state centralized batch production and the various stages across that supply chain, and then started to use our continuous pharmaceutical processing know-how. So this has been published in the book chapter in the book shown here. And here we've started to look at what's the scale of the technology for continuous processing, what are the throughput rates we can expect of a microfactory, and what are the different distribution options and co-location options, and their implications on inventory and service. Now, distributed manufacturing is not just about the technology. And in this paper just published, we start to look at some of the other aspects we need to consider when looking at co-location or distributed. Now, distributed manufacturing in the operations management domain is often referred to as multi-domestic manufacturing, where you had factories in many locations. And we would examine these from a network configuration perspective in terms of network structure, technology and process, governance, and the product architecture. But in this paper, we also identified local provisioning of institutional capability, human resources, as well as physical and technological infrastructures. So that local capacity and capability has to be there, that value provisioning, in order for a distributed model to become workable and reliable. So just to wrap up, in our work this year, we've been looking at the design of microfactory digital supply chains, from molecule selection, process technology constraints, and how that impacts supply network analysis. We've been leveraging applications in other sectors, in fast-moving consumer goods and consumer electronics, to understand the realities of a distributed manufacturing model. Future development is really targeting new design and analysis tools that are visual, interactive supply network design-based tools. And this should allow users to make tactical decisions about whether manufacturing operations are better co-located or not. And again, extending our AHP work, looking at structural modeling techniques for expert-driven technology selection to support decision-making on footprint options. And finally, looking ahead, can this work explore microfactory implementation for particular medicine supply chains, such as specialty or clinical trial medicines? And there's a number of funding opportunities that arise to explore microfactory supply scenarios, their cost and service levels, and can this provide a feedback loop to a more adaptive trial design? Finally, I'd like to acknowledge my colleagues, Dr. Atray Satani and Dr. Parminder Aulak, who have been co-workers in this research exercise. For further information on any of these research topics, please feel free to contact me on my email address. Thank you very much.